welcome to Algebra 2 with Mr. Clausen. Today we are going to make our way around a sine function today, and specifically I want to talk about how we can use the unit circle to find some common values of y. We'll take a little bit of time and talk about how we can find the amplitude or period of a sine function. And then I want to finish this video by showing you how you can sketch sine functions with some of the knowledge that we've talked about previously in this course. So without further ado, let's get talking about something. And one of the things that you should have some idea about at this point is that the sine function, in terms of a unit circle, is corresponding to the y value. So, if we go sine of theta, we know that's the y value of the coordinate pair that comes from the unit circle. And so one of the things that we can do is if we look at pi over 6 radians of the unit circle, we know that this is equal to 30 degrees. This would make a 30, 60, 90 triangle. All right, and if we look at the height here, which is going to be equal to 1/2, or the square root of 1 over 2, all right, that means that when we go pi over 6 radians across a sine function, the height of that point is equal to 1/2, assuming the radius of our circle is equal to 1. All right, and so when we reach that point, that also indicates the amplitude of our function is also equal to 1. And then at pi over 3, this is 60 degrees. We know at 60 degrees, if we went and carried across our unit circle, this would be the square root of 3 over 2. And so at pi over 3 or 60 degrees, we know this value, this green line, is the square root of 3 over 2. And then at pi over 2 or 90 degrees, we reach the maximum value that is associated with a sine function of 1, assuming a radius of 1 of our circle. And so this value is equal to 1. And what I just want to point out here is that if you look at the unit circle and we think about sine as a periodic function instead of a point on a unit circle, what we have is that the sine function goes over this period, which is just a portion of a circle, right? And if you think about this circle almost cut in half and flipped around, where the first half of a sine function is the top half of the circle, and the second half here is the bottom half of the circle, you can think of the sine function as this periodic function that represents all the different y values across the circle. So why is this important, and why am I telling you this? Well, I'm telling you this because we can actually anticipate a lot of the behavior of a sine function based on this unit circle idea. So if we think about, the point 0 here as kind of our origination point, and we go, all right, what is the sine of 45 degrees? Well, the sine of 45 degrees is this pi over 4 point, and if we look at pi over 4 and look at the height of this point, right, this is 45 degrees. The sine of 45 degrees, according to the unit circle, if we look at the y value, is simply equal to the square root of 2 over 2. If we look at the sine of 120 degrees, okay, at 120 degrees, boop, boop, that's 2 pi over 3. If we look at 2 pi over 3, which we don't have clearly identified, but that's about right here in terms of our line, all right? And if we go and we sketch this, as again, assuming this is 2 pi over 3, all right? That's 2/3 of a pi. Well, we look at 2 pi over 3, the y value is the square root of 3 over 2. We know that if we're following along a sine function and we're evaluating at 2 pi over 3, this value is the square root of 3 over 2. And very quickly, 180 degrees. Well, 180 degrees is equal to 1 pi. We go 180 degrees, that's 1 pi, that's this point right here. We can see that the sine function is equal to 0. At 240 degrees, that's 180, 210, 240, so that's 4 pi over 3. Okay, so 4 pi over 3 is going to be somewhere around here. let me think. Oh, yeah, it's actually right here. This is 4 pi over 3. And if we go and we'll look at that and we want to know the value of that point, hey, let's just go to 4 pi over 3, or 240 degrees. 4 pi over 3. The y value of 4 pi over 3 is negative square roots of 3 over 2, which if we look across that point, that makes sense. So instead of going and plugging into your calculator necessarily and getting a decimal, if you start kind of wrestling with this unit circle and trying to get an understanding that a periodic function like this is just the unit circle repeating itself over and over and over again, where from 0 to 2 pi represents one circle, or negative 2 to 0 represents one unit circle rotation, you can keep going through this over and over and over again. All right, if we look at 300 degrees, that's 5 pi over 3 radians. If we're looking at 5 pi over 3 radians, that's 1/3 pi lower than that of the complete 2 pi cycle. Well, you know what? That's right here. And if we go and look at this point, this is also negative square roots of 3 over 2. And very quickly, we can just pump all these through. At pi over 2, all right, at pi over 2 radians, let's just draw the line up here. It's equal to 1. If we look at 3 radians, well, that's not quite a pi. Now, when I say radians, this does not mean 3 pi. What this means is that it's 3 radians, all right? And sometimes you have this. So if you think of a pi being equal to 3.14 radians, 3 radians is almost 1 pi. Okay, so if we go 1 pi and we're saying 3 radians, we're talking about a point like right here. And so we can say that 3 radians is approximately 0. And if we say 3 pi over 2, look at 3 pi over 2, we're looking at this point right here. This is the 3 pi over 2. This is equal to negative 1. And if we look at 7 pi over 4, 7 pi over 4 is right here. Let's go down. We're trying to find that point right there. Well, if we look at 7 pi over 4 on our unit circle, assuming a radius of 1, if that radius is 1, then the amplitude of 1 corresponds to that. This is negative square root of 2 all over 2. Okay, so some of the stuff that we've been looking at all correlates and corresponds to the given situation that we're looking at. So with some of that knowledge, you have a basic idea of like what a basic sine function does. And now what I want to look at a little bit is how we determine the period or amplitude of a function. And one of the basic things that we see with a sine function, if we see y equals a sine of bx, I'm not too worried about the horizontal and vertical shift yet. We'll get to that in a later video. But what I want to point out here is that this is a normal y equals sine theta example. All right, so at 0 degrees, it's 0. At pi over 2 or 90 degrees, it's 1. At 180 degrees or pi, it's 0. At 270 degrees or 3 pi over 2, it's negative 1. And at 2 pi, it is equal to 0. And what you're going to notice is that from 0 to 2 pi, you have one cycle. And whenever we're trying to determine the period of a function, we can see that there is one cycle from 0 to 2 pi. So the period is equal to 2 pi. And you might be like, well, that seems pretty simple and rudimentary. And whenever we're looking at a sine function, the reason that we want to be able to find the period of an amplitude of a set of data like this is that whenever we're looking at the sine function and we see that there's one cycle, that's actually what the b value is. The b value is what I call the number of cycles, or sometimes I like to think about it as a accelerating term. All right, so for example, what I mean by that is that if I look at a function like this blue guy here and I go, oh, if I go from 0 to pi, this is one cycle. And if I go from pi to 2 pi, that is yet another one cycle. And the cycle here that we're looking at, they both have a period equal to 1 pi. And so if we want to write out a sine function for this, we see that the amplitude is 1. What you do is you go, well, how many cycles are there from 0 to 2 pi? Well, from 0 to 2 pi, there are 2 cycles. Number of cycles from 0 to 2 pi. There are 2 cycles from 0 to 2 pi. So if we go 2 pi and we divide by 2, we know that the period is equal to pi. And this relationship is always true. This is true for all sine functions. So what that tells me is that the period is pi and the accelerator value, or the number of cycles from 0 to 2 pi, is 2. Well, this b value here is the number of cycles from 0 to 2 pi. And we're going to ignore this stuff for now. We're going to say for a later date. And if we're looking at this given circumstance, how we're going to actually write out the sine function for this is we would just write it out as y equals sine of 2 times theta. Okay, so the b value is equal to 2. The a term, or amplitude, is equal to 1. And we just have theta, or x, here in terms of other term. And the same keeps holding true as you increase the number of cycles that happen between 0 and 2 pi. So if I'm looking from here and I see it repeats here at pi over 2, that's one cycle. At pi over 2 to pi, that's another cycle. At pi over 3 pi over 2, that's a third cycle. And from 3 pi over 2 to 2 pi, that's 4 cycles. And so what I'm going to look at here, if I want to determine what the period of this function is, I see that the period is equal to pi over 2. So I can either go and say the period is pi over 2, rearrange this equation and say b is equal to 2 pi divided by the period of pi over 2, and I can see that the b term should be equal to 4, or I can say, well, pi over 2 goes into 2 pi 4 times. And if I see that that is the case with this red sine function here, I see that the sine function for this should technically be y equals the sine of 4 theta. All right, and so this gives you some really quick kind of ideas to look at. And if you look at the unit plan sheet that I gave you, I break down all the different relationships. This period function is something that you need to know and how to use and apply. We'll talk about the h and the k value a little bit later, but right now you need to be able to find period and number of cycles between 0 and 2 pi. Now amplitude, if we look at amplitude, what I'm going to show you here on this graph is these are both y equals, those are wrong. These are wrong. Get a little bit more formal on a later date here. But so this is sine of x here. But when we look at a function like this, what we're looking at is we're looking at the amplitude of the function. And the amplitude is affected by the a term here. And when we're looking at this and we're trying to figure out, hey, like how does the sine function change when we increase the amplitude? Well, if we look at the unit circle, all we're doing when we increase the amplitude to 3 is we're changing the radius of the circle. So what happens is that this is still a sine of x function. There is still only one cycle from 0 to 2 pi. And so what this means is that if there is only one cycle every 2 pi, that means b is equal to 1. But if the maximum amplitude is at 3 to negative 3, and we take that number by 1/2, the amplitude a is equal to 3. So the sine function for this green line is not 3x. I should check and see what website that came from. But this is y equals to 3 sine of x, and is the value that is represented here by this function. So let's look at this graph and let's figure out what the amplitude and what the period is. Okay, so remember that if we want to simplify this out, let's just write the simplified sine equation here. Y equals a sine of b theta. Theta is your angle measure. B, which is equal to 2 pi over the period, or is often looked at as p over 2 pi of b. Again, remember b is the number of cycles, and this guy is just your amplitude. And so if we want to know what this given sine function is, we can tell just by looking at it here. So again, I'm going to go and I'm going to look, and I'm going to go up, down, up, and I can see that this is one cycle, and this is one cycle that has a period of pi. So what I can do is I can plug in pi for p here, and I could see that the b value should equal 2, or I can just go and continue this on a little further and say, oh, there's 2 total cycles. And if there's 2 total cycles, that means b is equal to 2. And the third part I'm going to look at here is I see that my max value is y equals 2, and my minimum value is y equals negative 2. And so my amplitude A is just 1/2 times the max minus the min. And so this will equal 4 times 1/2, so the A value is equal to 2. So my B value is equal to 2, my A value is equal to 2. So the sine function here represents y equals 2 times sine of 2 theta, and that would be the function that I plugged into Desmos and then plugged into the screen. So giving you some ideas about how we can look at some functions and just determine what the sine function actually is. All right, so let's talk a little bit about how to sketch a sine function. So what I want to talk about is how to write an equation and sketch one cycle of a sine function, assuming a is greater than 0, so we're not doing any negative sine function here. And we're going to say it has an amplitude of 4 and a period of 2 pi over 3. Well, let's pull out our useful equation here again. Y equals a equals sine of b theta. So they tell us that a is equal to 4. That is the amplitude. And b should be equal to 2 pi over the period. Well, they tell us that the period is equal to 2 pi over 3. So b must equal 2 pi divided by 2 pi over 3. These will cancel. The denominator of a denominator becomes a numerator. So b is simply equal to 3. And we would see, based on this information, that the function here would just simply be y equals 4 times sine of 3 theta. And that means, since b is equal to 3, that there will be 3 cycles between 0 and 2 pi. So if I'm looking at this, what I'm going to do is I'm going to say, all right, this is 2 pi here. This is pi. And let's just do from negative 2 pi to 2 pi. So negative pi, let's go negative 2 pi. All right, and so there should be 3 separate cycles from 0 to 2 pi. So what I'm going to do here is I'm going to say, okay, we'll say that a 0 should be here, and then there should be another 0 about here. All right, and so I'm just splitting the 2 pi into thirds. And so if I'm looking at this again, all right, this is going to be, let's say this is 2 pi over 3. Let's say this is 4 pi over 3. And then we add another 2 pi over 3 to that, and we'll get to 2 pi. This is negative 2 pi over 3. This is negative 4 pi over 3. Okay, just picking the convenient points here, okay? Because these are the lengths of the cycles. So what we're going to do is that we have an amplitude of 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. And so crosses in the middle. Maximums here. Minimums there. And so we'll just draw this out. And then we'll repeat. And probably not the prettiest sketch you'll ever see, but what we'll do here is we're just going to kind of go in the middle between those. All right, and so what you should see, 1 cycle, 2 cycle, 3 cycle from 0 to, or negative 2 to 0. From 0, 1 cycle, 2 cycle, 3 cycle to 2 pi. So from 0 to 2 pi, there's 3 cycles. And this is really a basic way that you can go and you can sketch these. The last example I want to hit, though, is how we can write an equation, sketch the wavelength for the color waves associated with Roy G. Biv. All right, and granted, I suppose this has changed a little bit because people say that indigo and violet are not 2 separate colors now. We just mush them together, and I mean, I tend to disagree, but, you know, that's probably me just being an old dude. So if we're looking at red, what I want to do is I want to look at and sketch sine waves for all these colors, because we know colors are created by photons and photons are waves. All right, and so if we look at red, all right, when we see a color like red, what we are actually seeing is the omission of other colors. All right, so when we see red, what we're actually seeing is 700 nanometer light, and then like orange yellow, that is, you know, around 580 nanometers. When we look at green, that's 520 nanometers. When we look at blue, for example, that's 480 nanometers. And if we lump indigo and violet kind of into one group, that's about 400 nanometers. And so what we can do is we can actually create a sine function for each of these wavelengths and see how they differ from one to another. And so let's say, you know, we're going and saying for, you know, this is 200, this is 400, this is, let's go here, 600, 800, 1,000, and let's call this 1,200. All right, and let's say we want to draw some sine functions out. Well, the trick to this is if you want to make a sine function, and let's say we treat the x-axis here as a length in terms of nanometers, and then y is just the intensity of the light, which would be a pretty typical situation here. What we can do is we can create a sine function representing this wavelength. And if we take the same idea that we've been exploring previously, where y is equal to a times sine of b theta. Well, b is the number of cycles between 0 and 2 pi. So what do? We say b is equal to 2 pi, and we divide that by the period. Well, what's the period of light? That's what a wavelength is. So all these values I have written here are different periods. And so if we want to know the number of cycles of something, what we would do is, let's say we sketch out red light, all right? And so from 0 to 700 here, from 0 to 700, what we're going to do is at about 350-ish, we are going to cross through the middle again here. And let's just call this 1 here. All right, and so what I'm going to do is a red wavelength is going to do something like this, where it'll go down and back up. So that's 700. Okay. And then 350, it'll intersect again. All right. And this is what a 700 nanometer wavelength would be. And if we want to make a equation for this, all we would do is put 700 in for the period, and that would be your B term. All right, so if you want a sine function for this, all you do is say y is equal to the sine of 2 pi over 700 theta. And we could simplify this a little bit and say that this is equal to y equals the sine of pi over 350 times theta. And this would be your wavelength for a red photon. So just for the sake of showing you, I will show you one other example. I'm feeling indigo violet. All right, so if we're looking at indigo violet, I don't have the ability to change the color in here right now. So, but if we want to look at indigo violet, I'll make this the same height as before, right? But if we're looking at indigo violet, what you'll notice is that we'll complete one cycle every 400 nanometers. All right, and so this is why indigo violet light is a lot more intense radiation, because you're getting way more wavelengths for every 0 to 2 pi region here. All right, and so if we look at this, this is more intense radiation than red light. And if you want to know what the sine function of this is, well, we need to find the b value. So the b value is going to be 2 pi divided by the wavelength, or the period, 400. And so the b value will simply be pi over 200. And so the sine function for this will be y, amplitude is 1, so it's sine of pi over 200 equals theta. And so you can get a little bit of an idea of what some of this looks like and how this works. So with that said, I hope that you got a good sense of how to find a period and amplitude and the number of cycles of a sine function, how to find some common values of a sine function using this knowledge of the unit circle that we've been going through. And with that said, let's do some math.